Okay, let's take a look today at the class activity for lesson 3, graphing. And as we did in lesson 2, the first part of this class activity is introducing you to a concept that was not discussed in the demo. So this is where you want to make sure you add this information to your notes so you can study it later as needed. So let's say we want to graph this equation, y equals 1 divided by x minus 2, by plotting points. So we let x take on a value and we find y, and we do something very similar to what we did in the preview activity. But it turns out if we were to let x equal 2, then we would be dividing by 0. So for example, if we let x equal 2, then our equation would look like this. And there is no number that defines this division. There's no number that defines 1 divided by 0. So of all the values that x could possibly be on the real number line, all real numbers, we cannot let x equal 2. So we say it's excluded from the domain of this expression. So x equals 2 is not allowed. It's going to be stopped at the door. It's not allowed because if we put x into this expression, it makes no sense. Any other number that we put in for x, this will be a real number. So we say that the domain of this expression, is a set of numbers. That's a key idea here, that it's a set. So you want to make sure that anytime you talk about a domain, you remember it's a set. And it's not just the number that's excluded. It's all of the numbers that are allowed in. So the domain in this case, if we use set builder notation, is the set of all x such that x cannot equal 2. It's excluded. If we use interval notation for this domain, remember, interval notation says it's any number from -infinity up to 2, parenthesis, because 2 is not included, and then we union that with all the numbers from 2 to +infinity. So on a number line, it would look like this. All the numbers up to 2, we have an open circle at 2, and then all the numbers from 2 to infinity. So you see it comes in 2 intervals, and therefore you have 2 intervals connected with this union symbol if we had interval notation. You can see here that set builder notation is quite efficient to represent this set of numbers. So if you're asked to find a domain of an expression, you say, what's going to get me into trouble here if I try to evaluate this expression? And if the expression has a denominator, you find the value of values of your independent variable x, or whatever it may be, that makes the denominator 0. Okay, let's take a look at another situation. There's one other way that we could get into trouble here when we're looking at domains, and that's if we're taking an even root of an algebraic expression. In this case, we're looking at a square root, because there's something we know that gets us into trouble here. That means we cannot define it, and that's if we have a negative number underneath an even root. So any even root, square root, fourth root, sixth root, we cannot have a negative number there. So we have to say, okay, when is this expression when is this expression equal to 0 or greater than 0? Because remember, this is the part that many students always forget. The square root of 0 is defined, it's 0, because 0 squared is 0. So to find the domain for this expression underneath the radical, You say, when is x minus 6 greater than or equal to 0? And you add 6 to both sides, and you see that it's when x is greater than or equal to 6. So in interval notation, you would use a bracket with a 6, comma, infinity with a parenthesis. And in set builder notation, you would say it's the set, so you use those curly braces, of all x such that x is greater than or equal to 6, and then you end with curly braces. Again, what's really important for you to recognize is that when you describe a domain, it's always some kind of set. This interval represents a set of numbers, and then set builder notation represents a set of numbers as well. So you'll have some practice with that idea in your homework. Now we're going to move on to using graphing calculators as well as algebra to solve some problems. So here's a problem that involves finding out when two linear equations are equal. So we have set up this situation here, a story, where we're renting a rug cleaner. And the first company that you could rent the rug cleaner from will charge you $22 as a flat fee plus $6 per hour. Company B will rent the same machine for $28 upfront, so it's a little higher flat fee, but the hourly rate is only $4 per hour. So the first thing we want to do is we want to establish the cost for each company. So to model the cost to rent the machine using two equations, we're going to let x represent the number of rental hours. So x equals the number of rental hours. And then we're going to let y equal the total cost. So since we have two companies, y1 is going to represent the total cost in dollars for company A, and y2 is going to represent the total cost in dollars for company B. Okay, so let's think about this. For company A, before I even start to use this rug cleaner, I'm going to be charged $22, and then I'm going to be charged $6 per hour for each hour I use it. So the total cost for X hours is 6X. Company B is $28 as a flat fee, and then $4 per hour. So each of these costs, Y1 and Y2, can be represented by straight lines. So let's take a look at how we would use algebra to determine how many hours of use will result in the total amount spent at each company being the same amount. So what will the total amount spent at each company be? All right, so first we need to find the number of hours, that's X, that will make both of these costs equal. So you may want to say, we want to find the cost for company A. We want to find the value of X that has the cost for company A equal to the cost for company B. So that means, when does Y1 equal Y2? Well, this is where you use substitution. Y1 is the same as this expression, 22 plus 6X. So your quest here is to find out when 22 plus 6X equals 28 plus 4X. The cost of company A, when does that equal the cost of company B? Okay, so to solve this linear equation, I'm going to subtract 22 from both sides. And I get 6X equals 6 plus 4X. Now I move this up. 6X equals 6 plus 4X. Now I subtract 4X from each side. And I get 2X equals 6. And then I divide both sides by 2, X equals 3. So this says that after 3 hours of use, the total cost that I would be paying company A is equal to the total cost I'd be paying company B. So let's see, what does the question ask us? What will the total amount spent at each company be? Well, in order to do that, I have to come up here and I have to substitute 3 into this equation. So let's do that. into each equation actually. 28 plus 4 times. So this equals 40 and this equals 40. So after 3 hours, now let's start it a little differently here, not after. If I rent the rug cleaner for 3 hours, the cost for company A will equal the cost for company B. That cost will be $40. Okay, so I've answered my question. The total amount spent at each company will be $40, and it's after 3 hours of use. Now, you could write that sentence many different ways. All right? In fact, I wrote it as 2 sentences, so I wasn't being very efficient here. What do you want for only 1 cup of coffee this morning? Okay, so how would we can see the algebra here, but how would we use, say, our graphing calculator to wind up with the same answers? 3 hours and $40. Let's take a look at that. Okay, so I have my handy dandy calculator out here. I'm going to clear the screen. So let's take a look at how we would approach a problem like this if we had a calculator available. So we're going to press the y equals button. And the y equals button is where we get to put in the 2 equations from this problem. So let's put in the 2 equations that we're using. The first one is 22 plus 6x. And the second equation, y2, is 28 plus 4 times x. Okay, so we've entered our 2 equations. We want to press second window, and that second window means that the little information that's in yellow above the window is the actual operation we're performing, which says TBL set. So that means if you do second window, you will be getting the table setup. So we want to set up a table, and we want to put in the numbers 0, 1, 2, 3, 4, 5 for x. So the table setup is going to start at 0 because x is starting at 0. And we're going to increment or change the values of x by 1. Now, if we keep auto and auto here, and we go to the table, which you notice is just above the graph, and it's yellow, so you say second graph, then this table will go from 0 as far as you want to go, okay, for values of x, and it will give you the different y values. So you can see here that before you even rent it, the first company A is charging you $22 and the second company is charging you $28. Many times when we set our table, we want to ask the table for very specific values of x. So you see here that you want to scroll down, use your down arrow to scroll down to the independent variable, which is x. So we scroll down with our little down arrow, and we're going to highlight, instead of it being automatically calculated, we're going to ask it to calculate for us. So you highlight the x and you hit the enter button. Okay. So now let's see how that changes things. So now we're going to press table, which is the top right hand button. It's second graph. And now you see you don't have any information in your table. But if I put a 0 in, it gives me the 2 values for y1 and y2. So if I put a 0 in here, I find out the cost for company A is 22 and the cost for company B is 28. So what values of my independent variable would I like to see the costs for? 0, 1, 2, 3, 4, 5. So my next value that I put into my table is 1. And I see that my cost for each company is 28 and 32. And then I put in a 2, and I get 34 and 36. I put in a 3, and I think from our previous example, we expect to see 40 there. Yep, 40 for each company. There we go. Then what happens after 3? Well, notice the first company becomes more expensive than the second company. And then at 5, this trend will continue. 52 and 48. So previous to 3 hours, when X is less than 3, the cost for company A is less than the cost for company B. When X equals 3 hours, the cost of each company is the same. And then when X is greater than 3, the cost for company A is more than the cost for company B. So you could use the graph or the table to determine which company you'd want to rent this rug cleaner from, depending on how long you wanted to use it. So we can see from the table what each cost is. How does this translate now to the graph? Well, we'll take a look at that in just a minute. So let's just use this information here that we just got. Use your table to find out how many hours will result in the total amount spent at each company being the same, and what will that total amount be? Well, we've already found that, but let's just go through the process again. So you're trying to find what value of X makes Y1 equal to Y2, and all you see it right here. Okay, so I will spend $40 regardless of which company I use, comma, if I rent the rug cleaner for 3 hours. So this is a little different sentence than I wrote before. I think it's a little more efficient. So again, this is how you would use a table to find the exact same answer that you found up here with the algebra. Okay, so if we think a little bit ahead, we notice here that X is 3 and Y1 is 40, and when X is 3, Y2 is 40. So that should correspond to a point on each graph, right? 3, 40 is a point on Y1, and 3, 40 is a point on the graph of Y2. So thinking ahead, that should be where they intersect. Well, let's see. Let's take a look at the graphs here. All right. So I'm going to call up my calculator again. And we talked earlier about setting up the window. So let's set up our window here. We go to Window. We don't need to have negative hours because that doesn't make sense here. So our X value, our X minimum value, here's our X minimum right here, X min, is going to start at 0. So that's where I want to put it. Let's put it over here, 0. And I'm just guessing 10 hours. Let's suppose I did no algebra. I would guess that maybe 10 hours might be an X max. Again, sometimes your window is a guess, and this says you're going to increment by 1 hour. Similarly, you won't be paying less than $0. Wouldn't that be nice? So you use your down arrow and go down here to Y min and set 0 in there. And again, you don't know how much money, and many times setting your window is a guess. So I'm going to say my Y max is, say, $60, or maybe that's the most money you have to spend. And again, we're incrementing by $1. So that's how we would set up our window. We don't want to use the standard window here since we don't want to use negative numbers for X or Y. And now we press the graph button to get a picture. So there's one of our equations and there's the other. So we'll talk about these two equations in just a minute. Let me take a little snippet of this picture for you so I can put it in and we'll copy it. And then hopefully it will paste right in. There we go. We don't need it to be quite that big. Reduce it a little bit, and there we go. So press the graph button and copy your graph in the space below. Okay, so we've done that. Can you figure out which of these two equations represents the cost for company A and which represents the cost for company B? I'll give you a minute to look over each of these lines and see if you can figure that out. Okay, so I used a little bit of color here to help us distinguish these two lines. So if you remember some stuff about plotting lines, you know that your constant value here, 22 and 28, represents the y-intercept, because when x is 0 in this first equation, y1 is 22, and in the second equation, when x is 0, y2 is 28. So if you look over here, the red line has a y-intercept that would be 0, 28, and the purple line has a y-intercept that would be 0, 22. So this would be an easy way to distinguish between the two. So y1 would be the one that has the lower y-intercept, the lower flat fee or initial cost. So that would be our purple. So this is y, oops, let's keep it our colors similar here. This is y1. And y2, which is red, so I'll write this in red. So here we go. y2 has the initial higher cost, and so that would be this straight line. Okay, so remember, we wanted to find, even though this is not a mystery anymore, we want to find where these intersect. Now sometimes you can just look at your graph and you see it's when x is 3. We can't see right now what the y value is, but we know that these two graphs intersect after 3 hours of use, and we're paying $40. But how would we use the calculator to find that point of intersection? So let's take a look at how we would do that. So for some of you who haven't used a graphing calculator before, this will give you all the steps you need to know. Okay, so here we go. To find out where your two lines intersect, press second trace calc. So here's my trace button. Second trace is now giving us a menu where we get to calculate various things. We're going to use the down arrow to scroll down to number 5, which is intersect, because that's what we want to know. Where do these lines intersect? So I'm going to scroll down to intersect. I'm going to hit our enter button. And notice you see first curve. And they want you to put a value in where you think these intersect. But the neat thing about this particular operation is you don't have to put in anything in. All you have to do is hit enter once, and then it asks you to do something like, where do you think this point is on the second curve? You just say, hey, wherever you are, it's fine. I'm going to enter again. And then it asks you to make a guess, and you just hit enter one more time, and it does all the thinking for you. Voila, x equals 3 and y equals 4. So that's how we use the calculator to find the intersection point 340. Okay, so I just took a little snippet of the graphing calculator screen and put it down here so you could see the coordinates for the intersection point. Interpret the point you just found in the context of this problem. Be sure to include numbers and units in your explanation. Now you're going to notice that we ask you to do this quite a bit, that it's very important when you describe a point of intersection, that you use both numbers in your sentence, the 3 and the 40, along with their units. So we could just come right back here to this sentence that I wrote just a minute ago. I will spend $40 regardless of which company I use if I rent the rug cleaner for 3 hours. So we'll just say CF. Okay. So you want to make sure your sentence includes 3 hours and $40. So your sentence has to have both numbers and both units. Okay. Now we're moving on to a little different type of problem. Oh, I want to go back and talk to you a little bit about these two equations and what we saw in the previous table. Notice that the cost of the the cost for company A is less than the cost of company B because the Y values of the purple line are less than the Y values of the red line until we reach 3, where we know they're equal. And then after that, the cost for company A is greater than the cost of company B. And that has to do with the slope of these lines. Okay? The cost of company A, even though you start out at a lesser cost initially, after some point, this slope of $6 per hour will make your overall cost greater. Initially, company B was at a higher rate, but the slope was less than the rate that you're paying per hour is less than the slope of company A. But initially, we're going to pay a little bit more until after 3 hours, and then that slope of $4 an hour makes the cost forever and ever actually to be less than company A. So again, that's the way you can take a look at these different graphs. All right, let's take a look at the next problem. A person lowers her hot air balloon by gradually releasing air from it. Let X be the number of minutes she's been releasing air from the balloon. I always write that out. Number of minutes releasing air. And Y is going to be the altitude of the balloon in feet. X minutes after she's released the air. So we're going to assume this relationship between how many minutes the air has been released and the altitude of the balloon can be modeled by this linear equation. So Y equals negative 200x plus 800. Hopefully it makes sense to you that the slope here would be negative, since when you release the air from the balloon, your altitude decreases. So X would be the independent variable, which would be the number of minutes after releasing the air. And this would be the altitude of the balloon in feet. So this problem here asks us, 4A asks us to find and interpret. That's important because you'll be doing this quite a bit. In the context of the problem, so the problem involves a hot air balloon, it involves the height of the balloon and the number of minutes. The coordinates of the x-intercept, be sure to discuss the meaning of both coordinates and include all relevant units. Again, you'll see this specific request over and over again right here. And you notice it's also down here on part B. Okay, so to interpret the x-intercept, let's find it. The x-intercept is where y equals 0. So I'm going to put 0 in for y, and I'm going to solve this linear equation by subtracting 800 from each side. I get negative 800 equals negative 200x. Then I divide both sides by negative 200, and x is equal to 4. So that says that after 4 minutes, what does that 0 there mean? It says your balloon is not in the air at all, it's on the ground. So after 4 minutes, my balloon, you could say, will be at 0 feet if you want to include that coordinate, will be 0 feet above the ground. My balloon will be 0 feet above the ground. Or, so now you see you have your 4 and your 0. You have your minutes and your feet. So you've followed these directions to include both coordinates and relevant units. But the sentence is kind of awkward. So you could say something like this. My balloon will be on the ground, because on the ground implies 0 feet after 4 minutes. of releasing the air. Okay. Now let's take a look at B. Find and interpret the context of this problem. So I know here at 40, the point 40, my balloon is on the ground. Find and interpret in the context of this problem the y-intercept. Well, let's take a look at the y-intercept. The y-intercept, if you recall, is when we let x equal 0. So that goes to 0, and y is 800. So that tells us that initially, before I release any air, my balloon is 800 feet in the air. And if I connected these two with a straight line, that would show over the first 4 minutes the height of my balloon at any particular time in that interval of 0 to 4. Okay. So how do I interpret this? This 0.0800. Lots of times I encourage students to take that ordered pair and insert the actual units right along each number and then make the sentence from there. Anytime you have a problem to interpret where you're looking at 0, in this case for your independent variable, we don't say at 0 minutes. You could say at 0 minutes the height of the balloon is 800 feet. But there's a word we use quite a bit in mathematics and in physics and science that takes the place of saying that time, in this case, x equals 0. The time is 0, and that's the word initially. So that implies the 0 minutes. So you can say initially, and then you'll still be following this direction up here that your coordinate is given by initially. Initially, the height of the balloon is 800 feet above the ground. Okay. How would you see all of this with your graphing calculator? Again, you would go in and you would put in, you turn it on, you'd put in y equal, let's get rid of these two equations that we were working with. So you'd put in negative, but to do negative, you have to use this little button down here, not the subtraction. Negative 200x plus 800. And now you might want to think about your window. Well, look, you already know that it's going to be on the ground after 4 minutes. So you don't want to use your standard window. So your window here would go from 0 minutes to 4 minutes. And you could use any kind of increment you want. Every half minute, every minute, doesn't matter. Let's do every minute. So this is x min. This is x max because it's going to be on the ground. This is your change in x. And then what about the height? Well, you know your height's going to go from 0 to 800, 0 being the minimum height, 800 being where the balloon started. So if you were to set up the window for this graph in this context, you would say, okay, x minimum is 0, x maximum is 4, because after 4, your height's going to be negative, and that makes no sense. Your y minimum of 0 feet above the ground, the maximum is where it's starting out at 800 feet. And now you hit your graph, and there you see the graph of the height of the balloon over the first 4 minutes. Okay? So what's interesting here is really the most interesting thing about this is setting up the window. So I'm going to take a little shot of that to show you how you would do it on your calculator. Okay, so as you can see here, here's the window for the balloon, and here's the graph that we get of the height of the balloon over the first 4 minutes based on this window. Okay, so again, a little practice with interpreting what the window dimensions means. Let's use the following menu and label the axis below. So again, this says x min. So you put a negative 16 there. X max. And you put a positive 16 there. And you're going to increment by 4. So 1, 2, 3 to 0, and we have negative 12 because that's an increase in x of 4. And then we increase again by 4, we're at negative 8, and we increase again, negative 4, and then 0, and then we have 4, 8, 12, 4, 8, 12. So there's your x-axis with a change between each x value of 4. So this is the change in x. And that little triangle here means change in x. It's actually the Greek letter delta. Okay, now we do y minimum. Our y minimum is negative 10. Our y max is positive 10. And then we're going to increment or change our y's by 2. So 1, 2, 3, 4. So we have negative 8, negative 6, negative 4, negative 2. 1, 2, 3, 4, 2, 4, 6, 8, 10. So that's how you would use this notation to create the scales on both your x-axis and your y-axis. Okay, now the next one actually gives us a graph, and it asks us to put in our window notation. So the easiest one to do here is your y-axis, because our y-axis starts at 3,000. That's our minimum value. It ends at 7,400, and it increments by 400. Now, I think we would accept 2 answers for the notation to use for the x-axis. Notice the label on the x-axis says ending year in the school year. Ending year in the school year. So what that really means is they want you to look at the end year. So if you take out the 200 in each one of these, you can see that this goes from 0, which represents the year 2000, up to 10. So 0, 10, and 1 is the increment. But my guess is that if you were doing this at home and you were just looking at the scale along here, you would probably say 2000 to 2010, incrementing by a year. So we'll take either one of these versions. It's okay to write any one of these. I think they're both reasonable choices here. All right, now finally we end this class activity with some true-false statements. And we've added these to our class notes and class activities to help prepare you for the types of questions you'll be seeing on quizzes and exams. So in this particular case, we have 3 questions that have to do with the material we've just been presented with. And it says, if your statement is false, make the necessary changes to produce a true statement. I used to also write or show a counterexample, which is an example that proves that your statement's false. Any of these would help. But sometimes students miss how easy it is to change the statement to show why it's false. So I want to give you a little bit of practice with that. The other thing I want to remind you is that every section in your textbook, just about every section, there's a few that don't, have true false questions in your homework problem set. And it usually appears near the end of the problems. So you could really best prepare yourself by making sure every time you do a section in the book, you go to your textbook, you look at the true-false questions, and you practice them. That's the best way and often on tests and stuff, these sections, true-false sections can be anywhere from 8 to 10 points. Okay, so let's take a look at the first one. If a point is on the x-axis, it is neither up or down, so x equals 0. Again, you should do whatever it takes to help yourself. You should draw yourself a little coordinate system here, and it says if the point's on the x-axis, put a point on the x-axis, and think about what would be the coordinates of that point. Well, maybe this would be 3, 0. So if it's neither above or below the x-axis, it's not the x value that's 0, it's the y. So this would be false. Now, sometimes students will actually give the counterexample, and they'll do something like this. No, y is 0. But another way you could say that this sentence is false is just to do x doesn't equal 0. And like I say, sometimes students write above it, it's y equals 0. So to get the full credit, and it's usually 2 points for a false statement, you have to say both false and then change your sentence so it's true. Let's take a look at B. If a point is on the y-axis, then x is 0. So let's take a look at that. Sure, if a point's anywhere on the y-axis, let's say 0, 8, x is 0. So this is a true statement. And then finally, the ordered pair 2, 5 satisfies this equation. So for it to satisfy the equation, you should be able to substitute 5 in for y and 2 in for x and have the left side equal the right side. And as you can see, 15 does not equal 0, so this is false. And all you have to do to change this sentence is just to put that, make that equal sign and not equal. Okay, I hope that helps you out with the class activities for lesson 3. Let me know if you have any questions.